Okay, let's try to understand the concept of potential difference in an electric circuit through a numerical problem. The question is saying how much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volt. So let's consider the 2 points as let's consider this electrical circuit. We're trying to depict whatever information given in the question as a diagram, as a circuit diagram. So there is a device. We're going to maintain a potential difference of 12 volt across this device. So we'll connect to a source of electric potential difference, that is a battery, that is cell. Battery means means combination of cells. So there's a difference between battery and cell. When more than when two or more than two cells combine together, they are connected in a series. That is known as a battery. So a combination of cell is not a battery. So there's a battery. So in a battery inside that there this chemical reaction takes place, and a battery, because of that, a potential difference in potential is maintained. And when it's connected to an element, to a circuit, then that potential difference is able to move electrical charge across it. When electrical charge start moving, we call electric current I. There's a flow, there's a flow of electric current when charges move. Charges move when there's a potential difference. Just like in water, and two levels of water, and suppose there's a pipe and it is horizontally kept, and there's water inside it, it won't move. But when you tilt it, there's a difference in the gravity, and because of that, water starts moving. So in a similar fashion, in analogous to two, electric current will also move when there's difference in potential. Not like gravity, but there should be when the potentials are same, electric current will not flow. When there is a difference in the potential, then only electric current will flow, and that difference in potential can be maintained by a battery, right? The question says that we are maintaining a potential difference of 12 volts, and if you want to move a charge of 2 coulombs across the circuit, so how much work will be done by this battery? The work done is energy will be consumed. So battery is like when electric current runs through it, its energy will be drained out. Its electrical energy will be drained out, moving those charges. So in order to move 2 coulombs of charges, how much energy will be spent or will be consumed, or how much electrical energy will be used up, or how much work will be done by this battery to move those 2 coulombs of charges across the circuit. So potential difference means what? It means the work done in moving electrical charges, or work done in moving unit charge. That unit charge is called 1 coulomb. How much energy is consumed in moving 1 coulomb of charge? It's called potential difference. So mathematically, so the relationship between the potential difference, the work done, the source of potential difference, and the charge is V is equal to W by Q. So this is the very basic equation which defines potential difference. Potential difference is the work done per unit charge, or work done in moving a unit charge. So if work done is measured in joule, the SI unit, and the charge is measured in coulomb, the SI unit of charge, so 1 joule per 1 coulomb is written as 1 volt. 1 volt, it's honoring the Italian scientist, the Italian physicist, Alessandro Volta. Then the unit of 1 joule per 1 coulomb in short form is called 1 volt. So how much will the potential difference of 1 volt? So if you're saying that the battery is able to maintain a potential difference of 1 volt, it means that in moving 1 coulomb of charge, in moving every coulomb of charge, 1 joule of energy will be utilized. In order to move for every 1 coulomb of charge, move around the circuit, 1 joule of energy is consumed. That means the potential difference maintained is 1 volt. So 12 volt means what? It means 12 by 1. That means for every coulomb of charge, 12 joules of energy will be spent. If it is 100 volt, what does it mean? For every coulomb of charge, 100 joules of energy will be spent. That much energy will be given out, or it will be spent. So you so understand 12 volts. So normally at our homes, whatever the electrical devices we have and the plug point we have, the electrical potential difference maintained is 220 volt. That means for every coulomb of charge that flows through your home or to the circuits in your home, for every coulomb of charge, 220 joules of energy is spent. That's what the meaning is, 220 volt. So if you understand this, let's use unitary method to find the answer, to find how much work is done. So what does it mean? 12 volt means for every coulomb of charge, 12 joules of energy is needed. So you write the statement for unitary method. The statement is written in such a way that whatever the quantity that you want to calculate, that and let it be there on the right side. So for every coulomb for transferring for moving 1 coulomb of charge, 12 joules of energy is needed. So for 2 coulombs of charge, multiply by 2. That's 24 joules. To move 2 coulombs of charge, 24 joules of energy will be needed. You can solve this question in this fashion by just using unitary method when you understand what does 12 volt mean. Otherwise, you can also use this relationship if you want to. In this relationship, there are 3 quantities. If you know 2 of them, the third one can be calculated. In this, the potential difference is given, the charge is given, so W can be calculated by multiplying V and Q. V is 12 volt, charge is 2 coulomb, 12 into 2 is 24 volt coulomb. This is known as which is equivalent to joule. So 24 joules of energy will be 24 joule of work will be done in moving 12 coulomb of charge when the battery is able to maintain a potential difference of 12 volt. I hope it's clear.